All right, 11.3 areas of polygons. Remember when we did rhombuses and kites, right? You need to remember that the diagonals are perpendicular, okay? So now, in order for us to find the area of a rhombus, okay, the easiest way for you to do is to remember, okay, the rhombus, the diagonals are perpendicular, okay? So I know this is a right angle, okay? You know that the area of the formula for the area of a triangle is half base times height, right? So you see you have 4 triangles here that have 90 degrees. So for each of these triangles, I can use one of these sides for the height and one of these sides for the base. Okay, so if I use this is the base, this is the height, I can just do area equals half 2 times 5. Okay, so notice that all the triangles are the same, right? 2 and 5, 5 and 2, 5 and 2, okay, and so forth. So the area of the triangles, okay, so I should put triangles here so we're not confused. I put this in the calculator, 2 times 5 is 10, and then divided by 2, I get 5. Okay, so now the area of the rhombus is equal to how many triangles do I have? I have 1, 2, 3, 4. 4 times 5, that gives me 20 square units. Okay, so again, split the shape up, okay, and try to find a triangle or something that is in there. For the rhombus, you have right triangles, so it's really simple. For a kite, okay, again, you need to check and see if in your reference sheet you have the formula for an area of a kite, okay? There is a formula you can take using the diagonals. You can take diagonal 1 times diagonal 2, right, and divide it by 2, okay? So here, right, we have this diagonal here, which is 2 plus 5, okay? So we can label this diagonal 1, and then this one here, from here to here, we can label this one diagonal 2, okay? So let's put it here, side note, diagonal 1 equals 2 plus 5, so that's 7. Diagonal 2 equals 3 plus 3, and that gives us 6. So here I can plug it into the formula. Area equals half diagonal 1 plus diagonal 2. If you put this straight in your calculator, you're going to get 21 square units. Remember also that another way for doing this is, I know that the diagonals are perpendicular, right? So here I have a 90-degree angle. So I can use this right triangles as well, right? 3 times 5 divided by 2. For this one also 3 times 5 divided by 2. This triangle is 2 times 3 divided by 2, and this one is 2 times 3 divided by 2, and add them together, just like we did for the kite, okay? So it's just 2 ways of doing it in case this formula is not in your reference sheet and you can't remember it. Okay, so let's take a look at a regular polygon. Regular polygon, we know that all the angles are congruent and all of the sides are congruent. That's what a regular polygon is, okay? So here we have this regular polygon. We have 1, 2, 3, 4, 5, right? All 5 sides have the same length, okay? And all the angles here also have the same measure, okay? These are all congruent. Okay, so now a couple of vocabulary words that you need to know here. If I draw a line from the center to the middle of one of the sides, right, so that it meets at a 90-degree angle, This line is called the apothem. Okay. If I draw a line from the center to the corner, right, one of the vertices, okay, that is called the radius, okay, of the polygon. This is going to be important because we're going to be using this information to find the area, okay, to help us find the area. So let's take a look here. Area of a regular polygon. The formula is half times A times P, okay? So P is the perimeter and A is the apothem, okay? So let's take a look at this example right here. Here, the apothem is 6, okay? The side length is 5. I have 1, 2, 3, 4, 5, right? So the perimeter is going to be equal to 5 times 5, okay? So the side length is 5, and I have, and the number of sides is also 5, okay? So that's why we do 5 times 5 for the perimeter. Perimeter equals 25. So now I have the perimeter, I have the apothem, so all I have to do now is plug it into the formula. The area equals half the apothem, which is 6, times 25. So if you put that straight in your calculator, you're going to get that the area is 75 square centimeters. Okay, so if you are in a regular geometry, okay, you can stop right here. Regular, stop here. Okay, and then if you're honors, keep going. All right, so let's find the area of this regular polygon. For this one, we're given the apothem, right? The apothem is, so the apothem is 8 centimeters, okay? Notice that this is a 1, 2, 3, 4, 5, 6, right? Is a hexagon. If I take and I draw the radius, okay? This is a 90-degree angle, okay? So because it's a hexagon, okay, I know that this angle right here is going to be 60 degrees, okay? So 360 divided by 6 gives me 60, okay? So this angle here is 60 degrees. And this angle right here is going to be 30 degrees. So this is a 30, 60, 90 triangle. So remember our shortcuts, okay? This is 60, this is 30, right? This is x for the short leg, 2x for the hypotenuse, and x square root of 3 for the long leg. So the long leg here is 8, okay? So that means that the short side, let's do the short side, right? Remember the formulas, okay? Is equal to 8 divided by square root of 3. Okay, remember that I have to rationalize this, and I end up with 8 square root of 3 over 3. Okay, so that's the short side, okay, which is this part right here, 8 square root of 3. Now, the reason why I'm doing this is because I need to know the side length, right, in order to use the formula, okay? So now I have this part. So the whole side is just going to be another one, right? So when I add these two together, I get 16 square root of 3. So area equals half, okay, apothem times the perimeter, right? The perimeter, I have 1, 2, 3, 4, 5, 6. So the perimeter equals 6 times 16 square root of 3. The apothem is 8. So area equals half 8 times 6 times 16 square root of 3. So when I put everything here, everything, all of this in the calculator, okay? Why did I put 1 over 8? It's a half. There you go. When I put this thing in the calculator, okay, you should get area is approximately 221.7 square centimeters. Okay, so remember, every time you have a regular polygon, you're gonna have to, if you need to figure out the side, right, you have to split this up into a right triangle there so that you can figure out the dimensions. All right, next one. Find the area of the square, okay? So here we're gonna have to use the same information. So here, this here is the radius, okay? Right, this is the radius. I can draw here the apothem, right? That's the A, right? Now I need to find here, this side. This is a square, okay? That means each angle is 90 degrees, right? This is split in half, so this is 45 degrees, which means this is 45 degrees. So this is, remember, a 45, 45, 90, okay? So that means the legs are both x, and the hypotenuse is x square root of 2. So the area of a square, right, is base times height. Before we do that, let's find what this part right here is, okay? So if this is, the radius is 3, right? Then I have to take 6 square root of 3, sorry, 3 square root of 2 divided by 2. All right, guys, sorry about that. So let's take a look here. We have the leg is equal to the hypotenuse divided by square root of 2, okay, for a 45, 45 triangle, okay? So here we know that the leg is going to be equal to 3, which is the hypotenuse, divided by square root of 2. Remember, we have to rationalize this, okay? So that means we multiply top and bottom by the square root of 2, and we end up with 3 square root of 2 over 2, okay? So this is the length of the leg right here, okay? So now we know we have to double it, right? Because this is also 3 square root of 2 divided by 2. So if we do 3 square root of 2 divided by 2 plus 3 square root of 2 divided by 2, we get 6 square root of 2 divided by 2, okay? So that means that this is each of the side of the square, okay? we can actually simplify this, right? And make this 3 square root of 2. So that means that each side of the square is 3 square root of 2. Okay, so now we do base times height, okay? So area equals 3 square root of 2 times 3 square root of 2, okay? Because this is also 3 square root of 2, base times height. So here the area is going to be, when you multiply radicals, right? You multiply the numbers in front. 3 times 3 is 9. And then 2 times 2 is 4. Okay? So we get 9 times 2, right? Because the square root of 4 is 2. And we get that the area is 18 square centimeters. A lot of work, right? A lot of work for this, okay? Just keep in mind the shortcuts. That should be helpful. If you don't remember the shortcuts, right? What can you do? You can use trig, opposite over hypotenuse, okay? And find out that way what the opposite is, okay? If you don't remember the shortcut. This one right here, I'm going to ask you to finish on your own, okay? But I'm going to help you just set it up. Here we have the apothem, okay? We don't know what that is. We know that the side length is 8, right? So I know that from here to here is 4. And here I can create my triangle, okay? My right triangle, okay? Now, if you do 360, right? Let's see how many triangles we have here. Look, this triangle, we have this triangle, we have this triangle, and we have this triangle, right? And if I split them all in half, right? Okay, because I want to figure out this angle right here, okay? So I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, so I have 10 angles. So I do 360 divided by 10, I get 36. Okay, so this angle here is 36 degrees. Okay, so now I have this. I'm looking for this because remember, for the formula, I need the apothem, right? Area equals half apothem times the perimeter, okay? The perimeter would be easy to find here. I just have to add them all up, okay? But I need to find the apothem, okay? So you're gonna have to use trig, okay? And I'll let you figure it out, which function you're gonna have to use, right? You have this angle, you have the 4, and you're looking for the x, okay? So opposite and adjacent. So find out what x is, and then find the area, okay?